For a decade or so, I've complained that physicists seem content with quantum mechanics as it is. They don't try to fix its problems. Rather, they tell themselves, and everyone dumb enough to believe it, that we must accept the quantum weirdness. By now, they've glorified the strangeness of quantum mechanics so much, it's become basically impossible for them to move beyond it. If something makes no sense, don't fix it. Give it a mysterious name and start a podcast. And yet today I have a team of physicists who've done exactly that. They've looked for the origin of quantum physics and found at least a possible one. That's intriguing because physicists said it's impossible. Let's have a look. One of the biggest mysteries on the foundations of physics is one you might never have thought about: causality. We're so used to it we never even think about it. Flip a switch and the light goes on. Cause and effect, simple enough. Unless you have children, in which case the effect just happens and the cause denies involvement. But where does causal order come from? Why is the world so neat and orderly? The authors of the new paper say, actually it isn't. Causality doesn't fundamentally exist any more than, say, a liquid does. A liquid is fundamentally made of particles, yet the particles themselves aren't liquid. That just doesn't make any sense. The liquidness is an emergent behavior for a large collection of particles. The authors of the new paper say causality is like that. It doesn't exist on the fundamental level. It's an emergent behavior that we observe for many quantum particles. The reason I find this interesting is not just that it could explain the origin of causality. It's also that causality is one of the reasons why it's so difficult to combine quantum physics with gravity. Physicists have been looking for such a combination, a theory of quantum gravity, for almost a century. But the issue is that any such theory of quantum gravity is a quantum theory of space and time. This means that it must have superpositions of different space and time structures. But the space-time structure defines causality. This means that a theory of quantum gravity no longer has causality. It has what's been called an indefinite causal structure. You can't tell whether the switch turned on the light or the light flipped the switch, which doesn't just sound nuts, but it's hard to make sense of mathematically. The new idea of the authors could solve this problem because you no longer have to combine quantum physics with gravity. Rather, both could come out of one deeper framework that has no definite causality. Actually, the idea isn't entirely new. It's just that until now we thought it had been proved to be impossible. The authors of the new paper now say, yes, it's actually possible. Their paper's very maths heavy, but it works with what they call a quantum box, or Q box for short. This is just any kind of quantum event that can possibly happen. You can think of it, for example, as an interaction of elementary particles. These quantum boxes are connected without any particular causal order, so you don't know which caused what. The authors of the paper then show that to get any consistent physics, you need to average over one side of the box's input. That one side becomes the past, and they call this process hyperdecoherence. Okay, actually, it's not what they did. It's what I think they should have done. They just introduced this hyperdecoherence and declare that there is a past and a future. I think, though, that this isn't necessary. You just need a time order for consistency. I give this paper a 5 out of 10 on the bullshit meter. The good part is that they show, indeed, you get quantum mechanics as we know and like it. The bad part is that they put in too many assumptions. It's a bit like baking bread and saying you've discovered flour. So let me be clear, this paper is not a new theory of everything, but I think it's a step in the right direction. I've become very frustrated with physicists who preach quantum woo, like the idea that we can somehow erase the past with quantum magic, or that a particle and its spin can be in different places, or the particles have negative time and similar nonsense. What these examples all have in common is that if you actually look at the maths, that's not what it says. At this point, I think physicists are just making up fancy stories for their calculations to baffle journalists. In any case, I welcome this paper because it's trying to replace quantum physics with a better, more fundamental theory that hopefully will make more sense. Or maybe we'll just be even more confused. The Fermi paradox just got so much worse. One of the most plausible explanations for why we've not yet heard of other intelligent species has been that technological civilizations eventually develop artificially intelligent systems, and it's not intelligent to populate the galaxy. They lose interest, basically. But in a new paper, a physicist now argues, quite convincingly, I think, that this is wrong. This isn't just interesting because of the Fermi paradox, but because it generally tells us how our attitude to space travel has been changing. The Fermi paradox is the question of why we haven't yet found aliens. The Milky Way has hundreds of billions of stars. We now know that planets are common and that many planets are quite plausibly in the habitable zones of their stars. Indeed, many of those planets should have formed billions of years before Earth. So why haven't we heard of any other intelligent species? Other civilizations should have had plenty of time to spread through the galaxy, build visible technology, or at least leave traces. But we haven't heard or seen anything from anyone. There have been lots of different explanations, for example, that the emergence of life is just incredibly unlikely, or that habitable planets are much rarer than we think. But one of the explanations that's attracted the most attention is that advanced civilizations simply lose interest in space travel because it's on a basic level dumb. Space travel is expensive and inefficient, and just exactly what is the purpose anyway? Humans currently attempt to travel in space for irrational reasons, so the argument goes, because of national pride, because they believe that more humans are better than fewer humans, or because they don't fully realize just how incredibly large the distances are between solar systems and how long it'd take us to travel there. But once a civilization develops artificial intelligence, they grow out of these silly ideas, so the argument goes, and instead they make their life cozy on their home planet, space traveling in virtual reality. Populating the galaxy requires too many resources with little result and is ultimately not sustainable. A related argument has it that civilizations just take it slowly for some billion years because computation becomes thermodynamically easier then. Quite the argument, seeing that I can't plan ahead enough to reliably water the plants. In any case, I've always found this an interesting argument because it basically pitches Elon Musk against himself. It'd lead you to expect that at some point Grok will begin to argue against SpaceX. Okay, but now here comes the new paper. The author argues that this earlier argument is fundamentally flawed. He says that once a civilization has artificial intelligence, robots, and space factories, space exploration doesn't require big and fast machines. It can be done with plenty of small, cheap spacecraft and with machines that need neither food nor air nor motivational posters. And that just makes the Fermi paradox so much worse, because now you have to ask not just, well, why haven't we received any electromagnetic signal from the aliens, but why have we not found any of their space probes? Why are they not here? The author gives multiple reasons for why space exploration is rational, most importantly the preservation of the species and possibly other species, knowledge preservation and scientific observation. If the cost of small probes is small compared with the value of these factors, then it makes sense. The author then also offers some estimates to show how his argument makes the Fermi paradox worse. He considers a 10-kilogram seed probe traveling at 0.01 times the speed of light. At that speed, it crosses 100 light years in about 10,000 years, and the galactic disk in about 10 million years. That's less than 0.1% of the age of the galaxy. This means that any civilization which has developed such technology should have spread their probes throughout the galaxy by now. Okay, but wait, this means there is another plausible explanation now for why we haven't heard of those extraterrestrials. We've simply looked for the wrong thing. So far, almost all searches for technosignatures have been to look for electromagnetic signals in one way or another, because the aliens would directly send signals or because they built structures around their star to extract energy and thereby dim it or similar. Maybe we should instead make more effort to look for alien probes in the solar system. Maybe some of those supposed asteroids are not asteroids. Maybe some of those supposed meteorites are not meteorites. Maybe some of those unidentified anomalous phenomena are not camera glitches. I think these are possibilities that we should take more seriously. That said, I give this paper a 10 out of 10 on the bullshit meter, not because it's bad or wrong, but because I think this isn't actually a scientific paper. It's more of a cultural speculation. But it's still interesting, and I think it's another sign for how much the conversation about extraterrestrials has changed in the past decade. Hello. Hi, Elon. Yeah, it's totally possible that aliens are here already. Well, I guess the first thing they do would be to get super rich and start a space travel company and build AI and robots. Oh, wait. A worker inside a US government high containment lab recently got bitten by a monkey carrying a deadly virus. The lab admin then didn't know what to do, simply because it's got no routine procedure in place. Someone else from the same lab then tried to smuggle biological samples from an mpox outbreak into the US. That comes at a time when worries about AI-generated bioweapons are at an all-time high, and the US government calls to cut funding for the National Institute of Health. Let's have a look. A bioengineered pathogen that's both highly infectious and lethal is currently the highest risk for human extinction. Such a pathogen could plausibly wipe out most of the human population, and seeing what happened with COVID, it's unlikely we'd be able to counteract the threat rapidly enough. The technology to engineer such a pathogen exists, and it's basically impossible to regulate. The remaining bottleneck is knowledge about how to do it, and the facilitator to get this knowledge is artificial intelligence. Anthropic's newest AI model, Fable, was equipped with safety measures so restrictive that it simply refused to answer even basic biological questions. But really, this just highlights the problem, which is the knowledge is out there, and it's just a matter of intelligence to put it together. Then again, the risk of malicious actors shouldn't distract us from the more immediate problem, which are simply incompetent actors. Consider this. On November 13th, 2025, a monkey infected with Crimean Congo hemorrhagic fever bit through a worker's protective equipment in a biosafety level 4 laboratory in Montana. The World Health Organization puts the fatality rate of the virus between 10 and 40%. 3 months later, another worker was potentially exposed to the virus while changing cages containing laboratory mice. These accidents happened in a laboratory run by the United States National Institute of Health, NIH for short. The workers eventually did not develop an infection, but the problem is that the lab administration clearly didn't know what to do, which now became clear from an NIH document provided by a whistleblower who simply said they don't have a real protocol. The worker who was bitten by the monkey was first sent to a hospital in Montana. Admin then tried to arrange an ambulance transfer to a different hospital in Washington, but first had to get extra approval from multiple governors. They tried to send blood samples to a laboratory but had difficulty finding a plane to get the job done. 7 months later, the whistleblower noticed they still hadn't established the necessary safety protocol, though the NIH insists that established procedures were followed. Meanwhile, the chief of the laboratory's virus ecology section returned from the Republic of Congo with tissue samples related to the mpox outbreak there. According According to a criminal complaint, he and a collaborator told customs officers that a case contained diagnostic equipment. Alas, officials opened it and found more than 100 vials, some of which contained deactivated Mpox virus. This comes at a time when the US government has called again to cut spending to the NIH dramatically, and the public health advisor Scott Atlas has called to abolish it. Cue the political left, which doesn't want to admit that the NIH has serious administrational problems and much of the money goes to waste, and instead insists that everything which comes from the political right is anti-science. And while they argue, shit happens and continues to happen. That dangerous viruses leak from laboratories is not a conspiracy theory, it's a very real problem. In the 1970s, anthrax spores escaped from a Soviet facility, killing at least 66 people, and smallpox viruses escaped from a laboratory in the UK, killing one person and infecting a second. In 2004, SARS escaped from a Chinese lab, killing one and causing multiple other infections. In 2007, a foot and mouth disease virus escaped from a lab in the UK and reached farms. Now look, I'm very sympathetic to the idea of tearing everything down and starting over from scratch, but this only makes sense if you can afford a period in which nothing works, and this just isn't the case for much of research in the NIH as much as elsewhere. Because make no mistake, we have the same problems here in Europe, we just don't talk about it. And really, I think this is the main lesson here. When it comes to AI, as much as when it comes to the missing safety procedures in labs, refusing to address problems doesn't prevent them from happening. Thanks for watching. See you tomorrow.